This is where we left off. We didn't get to do this application problem. Uh, the uh, the problem is, this is a tax table, and there will be tax has to be computed according to this. So you have to get the income from the user, and then calculate the tax. And then if the tax is over 15,000, you're supposed to discount it by 2%. We went over that, so I'm going to quickly go over that again. When you write the, clearly we need if-else statement. To handle this kind of situation, you need nested if. So I can begin with the salary, income being below 20,000 as my first, the first statement can be if income below 20,000. Or you can start at 50,000. Either way, you can finish it with the if-else structure. So I'm going to start with below 20,000. I'm going to have to get the income first, and then. So here's my statement: enter income, C in income, and then if income is less than 20,000, tax is just 5% of the income. Now don't do that the 2% deduction, until after tax is computed. Else if, that means the second bracket is 30,000 or more, but below 40,000. But that doesn't mean I had to write two inequalities, because already I have written income below 20,000. So only if income is not below 20,000, it will go to the else part. So that means it is already over 20,000. I don't have to check this part. It's a common error to write that second inequality, which is unnecessary work for the computer. Comparison is also work, so you should minimize the work. So below 20,000, after that, I only have to write this because I'm writing else. So let me go back to the program. So if income is less than 20,000, it'll calculate the tax this way. Otherwise, only if income is not less than 20,000, it'll go to the else part. There, I only need to compare it against 30,000. If you do unnecessary comparisons, you'll be losing points. Your program has to be efficient, so minimum work for the computer. So if you write unnecessary things, that's more work. So if income is less than 30,000, the tax is 6%. This else will be executed only if income is not under 30,000. So I don't have to compare against 30,000 again. I only have to compare again 40,000, and tax is 8%. Again, else if income is under 50,000, tax is 10%. Finally, there is no other if needed. So else, that means if income is over 50,000, that's when it comes here, and 12%. And finally, we just have to now compare the tax against 15,000. If it is over 15,000, then reduce by 2%. And then you can write the output. That's the tax amount. Okay, so now let's do a warm-up exercise. So I'm gonna have to see you write this. You can either write it in the chat or present it, on the camera. I have to see you write. So please try to write. I mean, if you don't participate, if you don't try these, you're not going to be learning. So that's the only way to learn. So let me see who can present the first solution. All right, before you go further, let me explain something. It says the furnitures are going to be discounted. If the current price is below 1,000, then it will be discounted by 15%. Okay, so then it says at the bottom, the discount is limited to 200. Okay, so what does that mean? Let me explain that. If the discount is going to be 200 or less, so whatever the discount amount you calculate has to be less than 200, otherwise it'll be equal to 200. That's what it means. You can only deduct up to 200. So that means when you calculate the discount in your if-else block, don't apply the discount. Don't calculate the discounted price. In other words, don't apply the discount. Let's just calculate the discount amount or the discount percentage, whichever you want to hold. So hold that number until the end. And at the end, you need to compare it against 200. If that discount amount is over 200, then you cannot apply that. You can only apply 200. So let me see how you handle it. You handle it your way. There are different ways to handle it. But one thing you need to do, one thing that's necessary is do not apply the discount within your if-else block. Just calculate the discount amount. All right. Okay, if anybody has a solution, go ahead and send it to me.
Professor,
Yep.
does the code require a user input?
Yes, you have to get the current price of the furniture.
Okay,
Yeah.
thank you so much.
You're going to do only one furniture right now. So you just ask for the price of one furniture and then determine what the discounted price is. Okay, I see something in the chat. I'm looking at David Back's solution, and you're writing else if price greater than 1,000, less than 2,000. You cannot write two inequalities like that, for one thing. And also, I just explained to you, you don't need to check that first thing. It goes to the else part only if the price is not less than 1,000. So that first inequality you have in the else if part, very first else if, should be eliminated, the first inequality. You should only compare it against the 2,000. Okay, that was for David. So you have double inequalities, which are not allowed. Some compilers support that, but the new version, I mean, the The standard version of the C++ does not allow that. So you can only write one inequality, but there is a way you can combine two inequalities that we'll be discussing in the next section. But you don't need two inequalities. You only need one inequality. Okay, so correct that mistake, David. Now I'm looking at Anissa's solution.
Ignore that one, it's wrong too.
Yes, you have the same double
Yeah.
inequalities. Double inequality should be eliminated. I just explained to you a minute ago that when you write else, the else is executed only when the first condition is not true, and therefore the condition you wrote in the if statement is not true means you don't need to compare against the same number again. Okay. If you're not good in typing, you can write on a piece of paper and show it to me. Then you have to tell me. I'm not looking at everybody, so you need to tell me that you're showing me a solution. Okay, I have another solution from Christopher. 5. Okay. Yeah, Christopher, you're right so far, but it's incomplete. After you calculate, no. You have price equal to 10% of price. No, because I'm sorry, I'm looking at Christopher. Okay. If price less than 10,000, price equal to 5% of price. That's wrong. You meant to put the 5% of price in another variable. You should not change price. You need to put that in another variable called discount or something. You cannot change the price right there. We need the original price.
Okay, sorry.
Right, to be able to discount it. So you're calculating discount and putting it in the price, which is erasing the original price. We cannot do that. So use another variable called discount to store the discount amount. I'm looking at Ivan's solution. You're applying 15% discount to the price. No, that's wrong. You cannot apply the discount. You can only, because the discount is limited to 200. So this 15% of price could be more than 200.
I'll change it right now, sir. I apologize.
All right. So you just calculate the discount amount and save it in a variable. And then take care of discounting at the end of the program after comparing against 200.
Would you take a look at my last one?
You have
I
another.
put an answer in the chat, please.
Yes, I see an Alexander's solution. I see Ivan's another one. So let me go in order. Discount price equal to this, discount price equal to this, discount price equal to this. Okay. All right. So you have calculated the discount correctly. I'm talking to Ivan. But then before you haven't applied the discount yet. So before applying the discount, so I see what you're doing. This statement, see out prices, discount price is the last line. You're only writing the discount amount. That's not discounted price. That's discount amount by which the price should be discounted. That's what that is. So, so you need to apply the discount, but before applying the discount, you need to compare it against 200 because it's limited to 200. All right. So before the see out statement, you had to compare the discount amount against 200 and make some adjustment. I want to see how you do it. There are different ways to do it. The discount is limited to 200 and you need to apply the discount to get the new price. You haven't done that. You're writing discount amount. 1 second. All right, let me look at Alexander's solution. Enter the price, see in price, and discount. Right, Alexander has the right solution. Very good. So far, one student got the perfectly right solution. Everybody else has.
Wait, Professor, could you go over mine? I sent
Okay.
it in earlier.
Oh, you submitted something earlier?
Yes, in the chat. You haven't gone over it.
David back and he's and okay, who is this? Who am I talking to?
This is Sam.
Sam, okay. There we go. All right. I have a solution from Sam. Else if, okay, else if equal to, right. Okay, Sam got it right. Very good. Two students got it right so far. The others are partially done, not completely done. When you write condition in the if statement, you cannot write double inequalities. That's not allowed in the new version, I mean, the standard C++. There are, some compilers support that, but it's not allowed because it's not in the standard C++. The standard C++ is what was agreed upon by the computer science community as the acceptable version of C++, and that doesn't allow double inequality.
Can you check mine?
Okay, let's see. Alexander, Anissa. Okay, I'm checking Anissa's new solution. Discount, 10%, 8%, 5%. Right, you got it right. Very good. Okay. All right, so that's good. At least 3 students got it right. I'm going to take one of your solutions.
Hi, Professor. I just submitted mine.
Okay, I'm going to look at it. All right. It's Kelvin, okay, Kelvin. You're using uppercase letters in the variables. You cannot do that. Discount.
Okay, sorry about that. I was actually using a text editor.
Okay, yeah, that's fine. If discount is over 200, discount equal to discount minus 200, that's incorrect. That's wrong math. The discount is limited to 200 means the discount amount cannot be over 200. It means if it is over 200, then you had to set it to 200. In other words, discount amount can only be up to 200. Understand? You're reducing discount amount by 200. That's not the right math.
Can I ask a question, please?
Sure.
I'm looking now on example which you said is right. And the discount equal price multiply on percentage. But when we multiply the price on percentage, we have only sum of discount, not the full price.
Yeah, the discount amount is
The price minus, right? Price multiply on percentage.
Yeah, that's the discount amount. And that discount amount is all you're calculating in the if-else block. And because discount amount is limited to 200, so therefore you cannot apply the discount until after you compare against 200. Okay. So that's why just calculate the discount amount, which is the percentage of the price. And then at the end of if-else block, we can handle the discount applying the discount. I'm going to explain that. If you haven't gotten it yet, then wait for my explanation. Okay, I'm looking at Chris Huang's solution. You are deducting 15% of discount, 15% from the price. So in other words, you are applying the discount and getting the discounted price in your if-else block. That's not right, because discount is limited to 200 means you should not be applying the discount. You should only calculate the discount amount, okay? And then only after entire if-else block is finished, you should compare the discount amount you have calculated against 200 to make sure it's not over 200. The discount amount is limited to 200, okay? So this whole program is incorrect.
Hi, Professor. I just resubmitted. Is the discount portion correct?
Okay, who, Kelvin? All right, Kelvin submitted another one. Okay, discount portion is right. Again, you have capital D, capital P. You cannot use any uppercase letters in the variables, okay? Just remember to correct that in your homework, but here it's fine.
Okay, Professor. I'll make note of that. Thank you.
Yeah. So 15%, 10%, 8%, and then the last. Now, what is, you look at your inequalities. LCIF 1,000 less than 2,000. That's wrong. You mean to say price less than 2,000, right? Current P.
Is that for me, Professor?
Yes, Kelvin. I'm talking to Kelvin. In the LCIF part,
Yeah.
inequality. I don't think you meant to write that. 1,000 less than 2,000. That's always true.
Oh, sorry.
You meant to write this current P less than 2,000. I think that's what you meant to write.
Yes, I did.
Okay. At the end, you're saying if discount is greater than 200, then that, and then, okay, everything is right, except the last line is you're writing discount amount. That's not what we need. We need the discounted price. Okay. All right. I copied one of your solutions. I'm going to put it up here.
So again, the else if statement that begins with below 2,000 just has to be below 2,000 for that part, right?
Price less than 2,000. Current price.
And then the next one would be a price less than 5,000, right?
5,000. That's right.
Okay.
All right.
Thank you, Professor.
You're welcome.
Professor, I have a solution. I'm gonna put it in the chat.
Okay, let me see. Okay, I only see Kelvin's solution as the last one. And who is this sending another one? Okay, so all right, I'm just going to go ahead and explain. I copied one of your solutions. I'm going to paste it here. And then I'll explain why this is correct. Okay, so you see, asking for the price and then reading the price into the variable price. And then if price is less than 1,000, discount equal to price times 0.15. So discount is calculated as 15% of the price. And then else if price less than 2,000. That is the correct way. You don't need to compare against 1,000 again. Only when price is over 1,000, it'll come to the else part. And there you only need to compare against 2,000. So if it is under 2,000, 10% discount. Otherwise, if it is under 5,000, 8%. Otherwise, just 5%. Okay, those numbers are right. And when that is done, you need to make sure that the discount is not over 200. So that's what the student is doing. If discount is over 200, put discount, so put the 200 in the discount. That's the easiest way, and it's clear for any reader what's going on. After that, take away the discount from the price and put it back in price. That's your new price. So you should do that only after making sure the discount is not over 200. And that's why if you write, like things like this, some of you wrote it, price minus this equal to price. That means if you write that, what are you doing? You're actually changing the price. You're applying the discount right there. But that discount amount may be already over 200 and you're applying it. That's wrong. You are not supposed to apply. So therefore, just calculate the price times 15%, or just hold on the 15% somewhere. You just need to say that somewhere. So discount equal to discount equal to price times 15%. That's the right way. You just hold the discount amount somewhere, and then you do this before applying the discount. Any question on that? Okay, so I'm glad to see that, there were
Thank you,
3 or 4
Professor.
students who got it perfectly right. Things like that, you have to pay attention to the details. And if you do this, if you apply the discount without comparing against 200, that's completely wrong. The program is going to produce wrong answers. That's not acceptable solution. All right, so that finishes 3.3, and you have one problem in your homework from 3.3. I have already set up the homework. The students wanted me to set it up early enough, so I did that this time. Okay, so let's move on to our section 3.4. Let me close that. All right, section 3.4 is about logical operators. So this is where we are going to learn how to combine several different conditions in an if statement. That we need to use logical operators to combine them. Okay, so sometimes we need to combine more than one condition in an if statement. We need to tell the system, all right, I want you to check this and this and this. If all of them are true, then do something. Otherwise, do something else. Or I want to say, if this or this is true, then do something. Otherwise, do something else. So you need to say and. In other words, combine 2 conditions and say, I want this and this to be true. Or sometimes you need to say, I want either this or this to be true. Only then I want to do this. So that's why there are logical operators called and operator and or operator. Logical and logical or. Logical and operator is 2 ampersand symbols. That means you're combining 2 conditions with the and operator. Or operator is the 2 vertical line symbols. In the keyboard, it's shift slash. Shift slash is the vertical line operator. You need to put 2 of those vertical lines. It means or operation. We're going to see what they mean next. You know that there are logical values we discussed, or Boolean values. Boolean values are and or. I'm sorry, true and false. True and false are the Boolean values. So these operators, the operators we are discussing now, the logical and logical or operators, apply to those values, Boolean values. Just like arithmetic operators apply to numbers, these operators apply to Boolean values only. So in other words, on either side of the operator, there should be a value true or false. It'll combine them into getting another result. Just like you add 2 numbers to get another number, and operator and or operator will operate on logical values, Boolean values, and it'll produce another Boolean value. So let's understand those right now. If you have an expression 1, this can be expression 1. The expression 1 can be any inequality or any condition, or even a Boolean variable, a variable that has a true or false. So it has to have a value true or false. Expression 1 should be a variable or inequality that will have value true or false. Expression 2 will be the same. And if you combine them with the AND operator, then the result of that operation will be a true only if both of them are true. And it'll be false if one of them is false. So, because that's what you mean normally when you say and. I want this and this to be true means only if both are true, it'll evaluate to be true. And when you say or, that means you're saying, I want this or this to be true. So that's exactly what it will do. It will come out to be true. The whole thing come out to be true only if one of them is true. And it'll come out to be false if both are false. So both have to be false to get a false out of it. So the logical expressions are something like val greater than 5, greater than or equal to 5, or even a logical variable can go there. Suppose that you have a bool type variable holding some true or false as value, that you can put that variable there. Okay, so you're going to see some examples next.
Quick question.
Sure.
In the or statement, if both are true, are they true?
Yes. So if one or the other is true, it'll be true. If both are true, still true.
Okay.
Or both are false, it'll come out false. Because that's what you mean when you say, I want this or this to be true. So one or the other or both have to be true for that to come out true. Otherwise, false. False happens in this case only if both are false. Okay, going on to the example. Suppose that k has a 5 stored in it, then k greater than 3 and k less than or equal to 10 will evaluate to be true because k greater than 3 is true and k less than or equal to 10 is true. Both are true, so it will be true. Let's look at another one. K greater than 3 and k less than or equal to 4 is false because k less than or equal to 4 is false for that same k. Okay, looking at some more simple examples. K has a 5 in it, so k greater than 3 is true, k less than or equal to 4 is not true. That's not true, but the operator is or. So therefore, we only had to have one of them true, and k greater than 3 is true, so therefore the result is true. K greater than 3, I'm looking at the next one, k greater than 3 or k less than or equal to 10 is true because both are true. So or means one or the other or both have to be true, and they're both true in this case. And k greater than 10, k less than or equal to 4. K greater than 10 is false, and k less than or equal to 4 is false. K is 5. Both are false, and therefore the result is false. So these are just simple examples. All right, so not operator, one more operator, the not. Now we already used not earlier in this way. We wrote something like if k not equal to m, something like that, means this exclamation symbol stands for not. So when you want to say not equal, this is how you do it. And that same not symbol, exclamation symbol, is a logical operator to convert logical values. So if you write not in front of a logical value, any logical value, logical expression, you're basically saying not that should be true. That's same as saying it should be not true. The expression should be not true. Essentially, you are negating it. It's just like putting a negative in front of a number, negating to the opposite value. Let me explain not operator. If you write not expression, then whatever the expression evaluates to be, the not will give you the opposite of it. So if the expression is true, not that will be false. If the expression is false, not that will be true. So that's why I'm saying that will be equal to true if expression is false. It'll be equal to false if expression is true. So that's negating, completely opposite. So these are the three operators: the ampersand operator, and operator, or operator, not operator. All of them apply to Boolean values, and you can use them to combine conditions in your if statements. You cannot write double inequalities. I saw that in some of your homework assignments, and also in your homework assignments, and after that I sent an email message to everybody that you cannot do that like this. Let me explain that again. Like this: if k less than m less than s, something like that. The compilers, some compilers accept that, unfortunately, but the standard C++ doesn't allow that. So you cannot do that. So if you need to combine them, to combine two conditions, and you want both of them to be true, then you can write k less than m and m less than s. That is the allowed way to do that. So now you're saying, I want this inequality and this inequality to be true. Only then I want the following to be done. That's what you're saying. So that's the only way. This first way is not allowed, so do not write that. The compiler you're using may allow that, but it's not permitted by standard C++. Okay, so let's do some examples now. K has a number -3 in this example. So let's evaluate not k greater than 0. The k greater than 0 is false, and therefore not k greater than 0 is true. It just gives you the opposite value. Here's another one. I have two conditions. K is 5 in this case, and k less than 0 or k equal to 5. K less than 0 is false, k equal to 5 is true, and therefore this whole thing is true, and not that is false. Interrupt me if you have questions, if you're not following anything. So therefore the value of this entire expression is false. All right, so here's a simple example of where you use them. I have x equal to 9, y equal to 5, and then if x is greater than y and x is not equal to 0. Say I only need two conditions to be checked, so I'm combining with the AND operator. X greater than y is true, and x not equal to 0 is true in this case. So x equal to x minus y will be done. So x will be changing to 4. The else part will not execute. Else part will execute only if this combined condition is false, but it is true. So therefore, the output will be 4. That's just, yeah, another example. X is 9, y is 5. So x greater than y is true, x not equal to 0 is true. So x equal to x minus y will be executed. That's the same example. Okay, it's just explanation of that. All right, so let's go to the next example. Val 1 is lowercase a, val 2 is uppercase a. Num is 97. So we have a combined condition with the not operator in front of it. Now notice that the not is there after parentheses. The entire expression is in parentheses and the not is in front of it. So that means the not will apply to this entire expression. So we had to evaluate everything in parentheses first. Val 1 less than val 2, lowercase a less than uppercase a is false. This first condition is false. Lowercase a is 97, uppercase a is 65. So that's false. Val 1 is uppercase, lowercase a, same as 97. So val 1 minus num will be 0. You're subtracting a number from letter, but remember they will be converted, both will be converted to the larger type, which is integer. And so 97 minus 97, that's what you're doing here. That is 0. So therefore, this condition is true. And so the entire condition is true because one of the conditions is true and the operation is or. So the not that will be false. So because the whole thing is false, see out val 2 will be executing, which will be printing uppercase A. So uppercase A is the output. All right, warm-up exercise. Let me see what you come up with as the output. Go ahead. Okay, anybody has an answer? Go ahead and say it.
I said -3.
Yeah, -3.
Same here, -3.
-3. Okay, 3 students said -3. Any other answer? -3 is wrong.
4.
4 is also wrong.
Oh, my bad. My bad.
-2.
That's 3.
3 is wrong. -2 is right. One student gave me the right answer. Okay, so I know exactly where you're going wrong. So let me explain. The statement is kind of written in a misleading way, but you know, system doesn't care. It'll just execute the way it can interpret it. And so A is 8, B is 5, so A greater than B is true. So therefore, B equal to B minus 5, A will be executed, which will replace B with -3. So B has a -3. And after that, there's another statement to execute, which is B equal to B plus 1. Because it is not in the else spot, it is outside the else spot. Remember, if you want 2 statements in the else, you have to put brackets around them. There are no brackets here. So the B equal to B plus 1 is outside the else, and that will be executed next, which will change B to -2. And therefore output is -2. All right.
So for clearer code, that would not be indented.
Right. This should not be indented. Like it should be like this.
Got it.
That would be the right way to write it. But if someone indented it, doesn't mean it's going to work differently.
Okay, thank you for the clarification, Professor.
I'm sorry?
Thank you for the clarification.
You're welcome. Yeah, I just wanted you to see that, when you read the program, you have to read carefully. There are no brackets after the else means only one statement is in the else, this statement, and this is outside the else. That means this will be executed regardless of whether the condition is true or false. So therefore, B will be incremented here, and therefore output is -2. All right, moving on. Now clearly we need to know exactly in which order these, we know that in arithmetic operators, if you remember, there is a certain order defined already in the language, and system operates according to that order, which is multiplication, division, modulus operators will be done first after the parentheses. Of course, if there's parentheses, that will be done first. After that, multiplication, division, modulus. And if there are more than one of those, it will go from left to right. And after that, plus and minus will be carried out. That's the order. So what about logical operations? These AND operator and OR operator, we need to understand the order for them. For logical operators also, parentheses first. So if you have parentheses, that will be done first. After that, not. Same way in math, in the arithmetic operators, if you have negation operator, that will be done before multiplication, addition, all of those. The unary minus, that's what we call it. So in the same way, the not operator will be done first, and it'll be done right to left. Now let me explain why right to left. If I write something like this, k equal to x greater than y, you write that, and then you put exclamation. Let's say k is bool type, so you're storing a logical value there, and you put exclamation here, so that means after evaluating x greater than y, you want to negate it. If you put another negation operator in front of it, then in what order should it be done? Well, after x greater than y, you'll do this first, and then do this. It makes sense to do that, right? But you normally don't write not twice. That means what? Back to original value. You don't normally write, but if you write it, then it will do right to left. The negation on the right will be done first. And same thing for the parentheses. If there are more than one parentheses, it will do the inner one first and then outer one. AND operator. If you have more than one AND operator, it will go from left to right, just like the multiplication and division. If there are more than one, it will do left to right. And if there is OR operator more than once, it will do left to right. But between AND and OR, AND is going to be done before OR operator. So parentheses and then exclamation, the negation, and then the AND operator, then the OR operator. So you have to remember this order. So if there is AND and OR, then you have to do the AND first. Okay, so let's do an example exercise, actually. I want you to evaluate these, and each one is going to evaluate to a true or false, and you just need to give me those. And you have to follow that order of precedence, otherwise you'll get wrong answer. Now I said not operator will be done first, but only after evaluating all the conditions. The conditions are evaluated first, of course. So m greater than 10 and n greater than 0, m greater than 2, they will be evaluated. They will become true, false. After that, not will be first, before and or. Unless you have parentheses. There are no parentheses anyway here. All right, I see some answers. Okay, one thing for sure is no matter how well you do with these, you have 50% chance to be right. And for the first question, Kelvin says it's false. And part B, he says true. I'm just checking. We'll go to the correct solutions in a few minutes. Ivan says false, true, false. True, false. False, true, true. Okay. All right. I have several answers from all of you. They're all different. Okay, so only Sam is right with all the answers. They are true, true, and false. First one is true, second one is true, third one is false. Okay, so true, true, false is the right answer. Okay, so let me explain. The first m less than n is false. N greater than 10 is false, but we are not evaluating or right now. Remember, and operator first. So therefore, n greater than 10, m greater than 6. This combination will be evaluated first. N greater than 10 is false, but m greater than 6 is false. So this whole thing is false. But then m less than n, oh, m less than n is also false. Why did I go wrong? So I was wrong. N greater than 10 is false and m greater than 6 is false. So this whole thing is false. And m less than n is also false. So it is false. I was wrong. Sorry about that. So the first one is false. I guess I rushed it. Okay, going to the second one.
Wait, I'm sorry, Professor. Could you go over that again? Why is A false?
Because the part that is, all right, all the inequalities will be evaluated first. So m less than n is false. N greater than 10 is false.
This is true because m is 5 and n is 8.
Right, n greater than n greater than 10 is false, right? M less than
M less than n is
right,
true.
M less than n is true. And so, okay. Yeah, sorry about that. I was right the first time then.
M greater than N. M, okay.
M less than N, M is 5, N is 8, so M less than N is true. All right, we agree on that?
Yes.
All right, let's evaluate next one. N greater than 10 is false. M greater than 6 is false. M is 5. So this combination will be done next. Remember, AND operator is done before OR operator. So this
So
combination,
wouldn't it make the statement false?
yeah, this whole thing is false now because N greater than if AND operator gives you false if one of them is false, and here both of them are false. So this whole thing is false. Now we have an OR operator next, and the right side of OR operator is false. This whole thing is false, but the left side is true. So therefore, the whole thing is true. Okay, because that's an OR operator. Any question on that? All right. So that's true. And going to the next one, N greater than 10 is false. N greater than 0 is true. M greater than 2 is true. Now, yeah. Okay, so next thing is to think about which operator will be carried out first. The NOT operator is first. So even though M greater than 10 is false, not M greater than 10 is true. The NOT will be combined to that because NOT is operated first before the other operators. So therefore, this will be true. And combining that with N greater than 0, this AND operation will be carried out first because it's on the left. And N greater than 0 is false and not N greater than 10 is true. So I'm sorry, not N greater than 10 is true and N greater than 0 is also true. So this combination will produce a true. And now going to the second AND operator, the left side is true. The right side of that is true, M greater than 2. So therefore, that will produce true. Okay, this has to be done first, but the NOT is done before AND operator. So therefore, not M greater than 10 is true, and N greater than 0 is also true. So therefore, the whole thing is true. After that, when you combine with this, it's still true. Okay, going on to part C.
C have false.
C is, yes, false. That's right. I'm explaining why. M greater than 10 is false. N greater than 0 is true. This AND operator will be done first because AND is done before OR operator. The NOT operator is first, but that's not going to make any difference. But let's do that. M greater than 2 is true and not M greater than 2 is false. But the next operation is not OR, it's going to be AND. So therefore, we need to do this next. M greater than 10 is false, N greater than 0 is true. So the combination is false. AND operator produces false. So we have a false on the left of OR operator and false on the right of OR operator. This is also false. So the whole thing is false. So the answer to this is false. Any question? All right, moving on. That's explanation for those questions. Now let's see an example of application. Application of these combining logical expressions. A company has decided to give salary raise to the employees. They have the following strategy. Those who have more than 5 years of service and currently making 25,000 or less will get 10%. Others will get 4%. So service and current salary, two things have to be compared. Okay, so we're going to get the service and the salary from the user. So salary and service are float type numbers. Ask for the service, years of service, and get the service. Ask for the current salary and get the salary. Then if service greater than 5 and salary less than 25,000, both are true, then salary will be raised by 10%. Otherwise, raised by 4%. Then write the new salary. All right, so it's very clear that AND operator is needed. Moving on, warm-up exercise. Assuming m is 10 and n is -4, determine the value of the following. All right, just tell me which operator will be carried out first. Not operator. So m greater than 10 is false, so not that is true. And leave it at that. Now the next operation is AND operator. So therefore we have to do this first. N greater than 0 is false. M less than 2 is false. So this whole thing evaluates to be false. Now we go to the OR operator. Right side of OR operator is false. Left side of OR operator is true. I'm sorry, false. M greater than 10 is false, so not that it's true. So it is true. So therefore the whole thing is true. The right side of the OR operator was false, but the left side is true. And therefore the whole thing is true. Okay, I want you to do the warm-up exercise too. Okay, to add up many things, I should explain that, adding up part. To add up many things, what you should do is declare a variable called sum to hold the sum of all those. Let me explain that part. Float, the numbers are integers, and yeah, integers, so the sum will be integer. So int sum. And then we are going to get, I didn't put semicolon for a reason. I'm going to have to come back there. Then we're going to get 3 integers from the user and add up only the positive and odd numbers. So among the 3 numbers, we are not adding up all 3. We are only adding up the positive odd numbers. Okay. So I declare the variable int x, y, z for the 3 numbers and ask for the numbers, enter the 3 numbers, and see in x, y, z. Okay, now I need to add up only the odd positive integers. So therefore, I start with the first one. If x is positive and x must be odd. How do I check that?
You check the modulus of 2 and it has to be equal to 1.
Right, modulus 2. X modulus 2 should not be 0. If it is 0, then it's even. So not equal to 0. X modulus 2 not equal to 0. If both of these are true, then I say add this to sum. So here's how I say that. Sum plus x should go back in sum. Okay, So if I do that, I'm saying to the current value of sum, add X and put it back in sum. If I do that, then there must be a current value for sum. And so you have to make sure there is a current value, otherwise this will fail. And that's why I have to go back to the first statement and store 0 in it. Some value must be there. So if I put 0 there, then 0 plus X goes back in sum, and sum is holding the sum of one number. So if this number doesn't qualify to be added, it will not be added. I don't need an else statement, because if this is all I need. If it qualifies to be added, then add it. And then I had to do the same for the next number, y greater than 0 and y modulus 2 not equal to 0. If these are true, then add to the sum. Y is added to the sum. Similarly, if z is greater than 0 and z modulus 2 not equal to 0, then sum equal to sum plus z. So I did it for all three numbers. So only the numbers that qualify to be added will be added. So sum will be correct when this finishes. So I see out the sum at the end. That's how you add up many things. Create a sum and set it to 0 first. And then whatever you need to add to it, you add to sum, put it back in sum. Add to sum, put it back in sum. Keep doing that as many times as you need. So that's a technique I wanted to explain. That's why I brought up this exercise. Okay, that finishes this section 3.4, and your homework includes one problem from 3.3 and all the even numbered problems in 3.4.